Previously, we worked with relations being a kind of connection between one thing and another. We talked about relations as ordered pairs, arrow diagrams, and EMAS tables. Now we're going to look at some other terminology that is present in functions that are a special type of relation. So again, I'm just going to reiterate that a function is a special type of relation. So the definition is that a function is a special type of relation where each of the elements or the parts of the domain go to exactly one element in the range. So there's some words in there. So an element is just a part. That could be a number, it could be a letter, it could be a name that relate one domain to exactly one range. So let's talk about what a domain is. A domain is all the elements, or all the parts in the first set. Typically, we'll talk about them as X's. A range is all the elements in the second set, or Y's. So our first example is we are going to determine whether the function or whether the relation is a function and justify the answer and identify any domain and range for each relation. So we see 4 goes to 2, 6 goes to 2, 6 goes to 3, 8 goes to 2, and 9 goes to 3. We're going to determine whether each relation is a function. So a function, again, is where the elements of the domain go to exactly one element of the range. So the x's can only go to one y. So we can see here that 6 goes to 2 and 6 goes to 3. So this is not a function. It's still a relation, but it's not a function. So it's not a function. Since 6 goes to 2 and 3. It goes to 2 separate things. Now, B, we're going to do the domain and range. Now, here's a new kind of step, new bit for you. We're going to talk about domain and range. Now, take it nice and slow. You can absolutely just write the domain as a capital D. But what you'll notice is that I don't write my D like this. I do a very fancy curly D. Now, if you want to see how that's drawn, and of course, in future sections, we'll be talking about domain and range even further. But just following this, D goes down, makes a loop at the bottom, comes up around, and a loop at the top. So we use a colon and a brace, which is just a squirrely bracket, and we notate our domain as our x's. So this is a fancy way of writing this. And again, we'll talk about this in future section when we talk about domain and range. But our domain uses our x's. We write a little bar. Just all that means is such that. All of our x's in here, we're just going to list them. Because these are actual elements. Now we'll talk about when we talk about functions, when we talk about graphs, we'll talk about how this next part changes. But for right now, all we have to worry about is that we're talking about our x's, and our x's are going to equal some certain numbers. That's 4, 6, 8, and 9. That's it. Our domain is all our x's that are 4, 6, 8, and 9. We do not have to write 6 twice because that's just, well, A would be wasting ink or wasting lead or graphite. But we don't have to write things twice. And we're going to also do the range. Now, you can absolutely just write a capital R, or you can choose to do the more fancy way. So here's what it looks like. And of course, I'll go over how you do that. I like going over how to do this because it's fun. So the domain one came down, makes a loop at the bottom, comes around, makes a loop at the top. Range goes down, comes back up, makes a little loop in the middle, and finishes off the eye. So range is actually our y values. So we're at colon, our brace, squarely bracket, bar, or a vertical bar, and it just says our y's are equal to 2s and 3s. 2 and 3. That's it. So I know that the domain and range part probably blows a little bit few of your minds, but that's fine. We'll be doing a lot more domain and range with more fancy parts. So let's go to another example. We're going to determine whether each of these are, or whether this one is a function. So once again, let's go over the definition of function. It's a special type of relation where each of the elements or parts of the domain go to exactly one element in the range. So from here, do each of these go to exactly one element in the range? So as you'll notice, this is an arrow diagram, whereas the first example was a set of ordered pairs. January only goes to 31. February, in this one, only goes to 28. March, only to 31. April, only to 30. Okay. So is this a function? Yes. Each month only goes to one number of days. Now, you might make the observation that February could have 28 or 29 days, but in 2023, where this video is being made, February only does only have 28 days. It doesn't have 29. We're not dealing with a leap year. 2024, that's a different story. February. So in 2024, we'd have 29, and then we'd have they're going to 2029, and there wouldn't even be the option of the 28. So it would still be a function. Now, if we change the question and say how many days could it have, well, then we'd have the February going to both. But that's not what this question is saying. We're just seeing exactly what it says right now. February goes to 28. Done. Alrighty. So now let's do our domain and range. Domain. Get into the habit of writing X's. So our X's, and let's do a little abbreviation. X's, January, February, March, and April. Done. How about our range? So our Y's, again, we're going to get comfortable with using Y's. Y is 28, 30, and 31. The domain is our X's. They're the things that are in our first set. Our range is our Y's. They're the things in our second set. So hopefully, the definition of a function actually makes sense. Now let's deal with two more definitions. An independent variable is something that has no dependence on another thing. It's completely independent. For example, if you were completely independent, you would not depend on anyone else. Whereas you are actually dependent. Actually, by law and everything like that, until you leave, you are still considered dependent under the Canadian government and Canadian law. But that's a discussion for a lot of social classes and such. But a dependent variable is something that does depend on something else. So our second example, it says that the table shows the cost of student bus tickets, C dollars for different numbers of tickets that are purchased. So the number of tickets, 1, 2, 3, 4, 5, related to the cost. $175, $350, $525, $7, and $875. So this is a relation. Why is this relation also a function? Well, if we go back to the definition of function, for each of the elements in the domain go to exactly one element in the range. Domain is the first set, range is the second set. So do each of the elements in the first set go to exactly one part in the second set? Yeah. One only costs $1.75. 2 only costs $3.50. 3 only costs $5.25. 4 is $7. 5 is $8.75. So each element in the first set comma goes to only one element in the second set. If we wanted to use more specific words, each number of tickets comma, spell words correctly, have only one cost. One ticket does not cost 2 different values. 5 tickets do not have 2 or 3 different values that they cost. Now, B says identify the independent variable and dependent variable. Independent variable and dependent variable. Justify your choice. So which of these are independent and which are dependent? So which one depends on the other? Well, if you're looking at it, the cost depends on how many tickets you buy. So cost is the dependent variable, and the number of tickets is the independent variable. Because technically, number of tickets could be arbitrary. We could say, yeah, we're just going to sell 17 tickets. Well, your next question is, what is that going to cost? Meaning that the cost depends on how many tickets you're buying. So the number of tickets is the independent, and the cost is the dependent. Our justification is, make that actually look like a C. The cost depends on the amount of tickets being sold or being bought. So this number of tickets, or let's use the right word, purchased. Now we'll write our domain and range. So our domain now we're actually going to use a slightly different variable for this one. Because we're talking about this being our first set, because you can see that 1 costs that, 2 costs that. These 1, 2, 3, 4, 5 is our first set. Now I'm going to change the variable from x just to an n. Why am I changing it to n? Because it's the number of tickets. So n is just going to equal 1, 2, 3, 4, and 5. Done. Whereas our range down, up, loop in the middle, and finish off our R. Our variable for range is C. Our cost, and I'll explain this part. Thinking section 4 is I'll explain this entire part. For right now, we just need to know this part. Cost is 175, 350. I believe the next number is 525. Yeah. Then $7, and then $8.75. There's our domain and range. Then started off with what is a function, domain, range. So those are the new parts. But it's not a huge extension. And define what a function is, adding in the learning of what an independent and dependent variable is. And I believe I usually put to section 4. Maybe it's section 5. We have made a full connection between a lot of this stuff. And you'll see that in just a few sections here. Now let's look at how this stuff is related in graphs. Oh, actually, no, I put it right here. Perfect. I have it summarized here. So functions are special relations where each element of the first set goes to exactly one element of the second set. Each domain goes to exactly one range. Each x goes to exactly one y. Each independent goes to exactly one dependent. So what we're noticing is that I'm just going to change that color, make it a little more obvious. So first set, domain, x, independent, they are all directly related to each other. Whereas second set, range, y, and dependent are also directly related. So just saying, I could say first set going to exactly one range. I could change these orders to say, okay, domain goes to exactly one y, or the independent goes to exactly one range. First set, domain, x, and independent all mean the same thing. Second set, range, y, and dependent, they all mean the same thing. So one way to determine whether a graph is a function is by what's known as the VLT. Oh, what's a VLT? Hopefully you can read some bold. It's a vertical line test. The vertical line test is just that if no 2 points can be joined by a vertical line, then the graph is a function. So other terminology that's typically used is one-to-one. So here's how a vertical line test goes. I'm just going to grab my line and change my color. Okay. Oh. There we go. All right. So basically, if I draw vertical lines all along a graph, if I only touch the graph, like that vertical, yep. If I only touch the graph once with any vertical line, it passes the vertical line test. So it's if no 2 points. So if only 1 point touches the graph, it passes the vertical line test. So if I look at this one, I just need to change my color. If I draw a vertical line right on the edge here, just making a tangent line, yes, this passes. Right here at -2, it passes. Right here at +2, oh, that line actually go perfectly vertical. That part passes. But as soon as I make a line anywhere in between -2 and 2, like there and there, or anywhere, here I'm only touching the graph once, but here I've touched it twice. If I have joined my graph by 2 points or even more, then this fails. So if it passes a vertical line test, it is a function. If it fails a vertical line test, it is not a function. So let's take a look at this graph, or look at these points. 4, 2. 4 on our x's, 2 on our y, and starting at our origin, go right and up. 6, 2. 6, 3. 8, 2, and 9, 3. So if I draw vertical lines, I draw a vertical line here. Oh, it only touches once. I draw a vertical line here. It only touches once. Draw a vertical line there. Touches once. I draw a vertical line here. It has now touched my graph twice. So therefore, this has failed the vertical line test. So it is not a function. Now this is the exact same as if, by chance, you might see a question that looks like this. Actually, so I'll do it in a different color. But if I were to draw a graph here and make it go vertical, so a reverse L, if I draw vertical lines here, I know that looks slanted. If I draw vertical lines all along here, it's good. But as soon as I hit here, so the original part was going all the way up to like there. Because it's overlapping with this entire L, it's actually, in technicality, there's an infinite amount of solutions in between wherever the top part is and the bottom part is, because you are dealing with every single decimal value that's in there. So it's failing here, 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 here. It has touched, our vertical line has touched the graph multiple times. And if it's touched multiple times, this one also would fail. So this is our pair. You'll notice, if you haven't, that this is actually the exact same example as the first page. We say it's not a function since the 6 goes to the 2 and 3. By graphing it, we see that fails the vertical line test. So it's still not a function. Because yes, the 6 goes to 2 and the 6 goes to 3. As long as you're able to justify which way, you are good. So if you're given a graph, I expect you to use the vertical line test. If you're given an ordered pair or a table or a graph, okay, sorry, graph is a vertical line test. But if you're given an ordered pair or a table or an arrow diagram, you can say, yeah, does each element of the domain go to only exactly one range? If it does, then you have a function. If it goes to 2 things, then it fails. It's not a function. But I just want to show you how this graph looks. So 2, 5. So 2, 5. 3, 8. Now we're not connecting these points because these are just individual points. We don't have an equation. We'll talk about equations in our next section. For -8. 5, 8. And 6, -3. So if I were to draw vertical lines here, now I'm actually going to make nice lines because that's going to make my life a lot easier. It's only touching the graph once. I can draw vertical lines all through. That's only touched once. No, our vertical line is only touched once. This one only touched once. And this one also touched once. So this one passes the vertical line test. So it is a function. Now, not all the ways will you be given a table, as well as I do have this specific example just to show. You can see that 3 goes to 8 and the 5 goes to 8. Well, this would be an example of what's known as a many-to-one situation, but we'll talk about many-to-one situations in pre-calculus 30. But just because 3 goes to 8 and 5 goes to 8, the 3 only goes to 8. The 5 only goes to 8. So it is still a function. If the 3 went to 8 and there was another, and this was a 3 and a 3 went to -8, then yeah, that's not going to be a function. But that's not what the question says. It says 3 goes to 8 and 4 goes to -8. Hopefully that works. And it's just kind of identifying those functions. You can rock and roll and have some fun.